Let's have the continuation of our lecture video in integral calculus with the topic Application of Definite Integral Centroid of a Plane Area by Integration, and this time in polar coordinates. In the previous videos, we were able to discuss how to get the areas of the plane areas in polar coordinates, and this is what we need to review for this lesson. Now, as for the centroid, we also have formulas for centroid, and here are the formulas to consider when we are solving for the centroid of a plane area in polar coordinates. So consider this figure of a polar coordinate, and we're looking for the centroid x bar and y bar. In order to get that, we need first to compute for the area inside the figure. And the formula for that is area is equal to 1/2 integral of r squared d theta from the lower limit to the upper limit. So lower limit alpha, upper limit beta. So in the previous video, we were also able to find or solve for the upper limits and the lower limits. Now for centroid, we have this formula for centroid. So this is the general formula. We have the A, or the area, which is this one here. The area, the x bar is equal to 1/2 integral of the 2/3 of r cosine theta times the area r squared d theta. Then the limits are alpha to beta. Now to simplify, we will have ax bar, that is 1/3 integral of r raised to 3 cosine theta d theta. Then the limits are from alpha to beta. Now for the y bar, we have the formula 1/2 integral of 2/3 r sine theta. So this differentiates the x bar from the y bar. So for x bar, we have 2/3 r cosine theta, but for y bar, we have 2/3 r sine theta. Then the same also, they have r squared d theta. To simplify, we have y bar is equal to 1/3 integral of r raised to 3 sine theta d theta. Observe that for x bar, you have their cosine theta. For y bar, you have sine theta. Okay? So let's solve the following examples. There's 2 of them. For example number 1, find the centroid of the upper half of the area bounded by the curve r is equal to a times 3 minus 2 cosine theta. Now in our previous video, we were able to sketch the curve by filling this table by using our calculator. Again, we will use that method again for us to compute for us to sketch the curve. Again, we must remember that if we are filling the data of the table, we will use here the degree mode. So make sure that your calculator is in degree mode. So what we do here is mode, then locate for the table, then type in the formula, which is the r is equal to a, that is 3 minus 2 cosine alpha x. That is equal to start. Our start here is 15 degrees. So we put there 15, ending 360 degrees. Step is in every 15 degrees. So we have here the value of the value of r in each theta. Now for 15 degrees, we have here 1.07A. Don't forget A because in the equation we have A here, so we will put A in the table. So this is 1.07A for 30 degrees. We have there 1.27A for 45 degrees, 1.59A. 60 degrees, we have 2A. 75 degrees, we have 2.48A. And then we have 90 degrees, that is 3A. For 105, we have 3.52A. Then 120 is 4A. 135 is 4.41A. 150 is 4.73A. 165, we have 4.93A. Then 180 is 5A. We need to stop there because in the problem it says there, find the centroid of the upper half. When you say upper half, we will just consider two quadrants, which are the quadrant 1 and 2. So if we are considering quadrant 1 and 2, so we will just fill the table on quadrant 1 and 2. Okay, so let's sketch the curve here. For 15 degrees, we have here 1.07, but let's start first with the bigger value for radius, and that is found at 180 degree, and that is 5A. So let's say this is 5A point here. Then next, in 120 degrees, we have 4A. So let's say, so if this is 5A, then this one here is 4A, a much lesser radius. This, what I'm doing right now is, I'm not locating all points. I'm just locating all the whole number and then just make some sketch. Then next will be the 3A at 90 degrees. So this is the 90 degrees. Then let's have 2A at 60 degrees. So let's say this is 2A. Okay. And if we see at 30 degrees, we have 1.27. And then at 15 degrees, we have 1.07. So it did not go to 0. It's just here. And sketch the curve. Or let's just connect the dots. So we have here the curve. Let's just say, there you go. So this is the area that we are considering, the upper half of the area. Now what we're looking for here is the, so from the introduction a while ago, we're looking for the X bar and the Y bar. So we will treat it just like the rectangular coordinate as for the location of the X bar and Y bar. So if you notice, although radius will come from the point of origin and towards the certain angle, the location for X bar is horizontally from the point of origin up to the centroid of the figure. And then for Y bar is vertically from the point of origin up to the location of the centroid. So same is true here. So what we're looking for here is the location of the centroid. So if this is the area that we are considering, the upper half, therefore we might assume that the centroid is located around here. So we are looking for the value of y bar and the value of the x bar. So looking at this, we are expecting that the value of x bar is negative and the value of y bar is positive. Okay? So first step is to find the area. So what is the area of this curve? So area is equal to, okay, let's put it here. So area is equal to 1/2 integral of r squared d theta. The limits are alpha to beta. Now, what is our alpha? For our alpha, we are starting from this point, then we go counterclockwise to this point. Therefore, our alpha is at 0 degree. Then our beta is at 180 degrees, or that is pi. So area now is equal to 1/2 integral of r squared is the, here the equation. So that is a 3 minus 2 cosine theta squared d theta. The limits are 0 to pi. Now in computing for this, we need to remember to use radian mode. So use radian mode in the calculator. Okay, to go back, let's go to mode, go to computer or calculator, then change the mode into radian mode. Then we have here integral of, so let's put the 3 or 3 minus 2 cosine alpha x squared. Okay, it is 0 to shift pi equals 11 pi multiplied with 1/2. That is 11. So area is equal to 11 over 2 pi a squared square units. So we were able to get the value for area. Next, let's have the value for x bar using this formula. So for x bar, we have here area or a x bar is equal to 1/3 of r raised to 3 cosine theta d theta alpha to beta. We're able to get the value for area as 11 over 2 pi a squared. X bar is equal to 1/3 integral of the radius is a 3 minus 2 cosine theta, that is raised to 3, then cosine theta d theta. Alpha is 0, beta is pi. So 11 over 2 pi a squared x bar is equal to, so this here will become so we have here 3 minus 2 cosine theta. So cosine alpha x raised to 3. Then cosine theta or cosine alpha x. Then 0 to shift pi equals, it is negative 30 pi. So what we have here is 1/3 of negative 30 pi or negative 30 pi a raised to 3. Then cancel 3, so that becomes 10. So what will happen here is, that is 10 or negative 10. So cancel here pi. So negative 10 over 11 over 2. So the answer here is negative 20. So x bar is equal to negative 20 over 11 a, or that is negative 1.81 a. Negative 1.81 a. So that's for x bar. Next is for the y bar. For the y bar, we have here the formula, and we will just change here to a y bar is equal to 1/3 of r raised to 3. It becomes sine theta d theta alpha to beta. Then area is 11 over 2 pi a squared y bar is equal to 1/3 of a 3 minus 2 cosine theta raised to 3 sine theta d theta 0 to pi. So 11 over 2 pi a squared y bar is equal to 1/3 of, so this becomes so this becomes sine alpha x. That is 78. So 78 a raised to 3, or 78 okay, so that's the answer, 78a raised to 3. So y bar now is equal to, what is 70? Oh, it's divided by 3. 78 divided by 3 is equal to 26. Therefore, 26 divided by 11 shift pi over 2. So that is equal to 1.5a. So y bar is equal to 1.5a. Therefore, centroid is at negative 1.81a and 1.5a. So that's for number 1. Let's go to number 2. It says there, find the centroid of the area bounded by the curve r is equal to a1 plus sine theta. So the whole area of this curve. So we need to compute first, or we need to fill the table first and sketch the curve. Again, when sketching the curve, we use the degree mode for the table. So degree mode, we need should be in degrees. Yeah. The degree mode, and type in the formula, the function 1 plus sine. We should go to the table first. Table, then the function 1 plus sine alpha x is equal to 0. So start 15 and 360, step 15. So that's the table. We now have at 15, so 1.26, 1.26a, 1.5a, 1.71a, 1.87a, at 75, that is 1.96. So yes, we are looking at the table using our calculator here. If we are doing a quick sketch, then we can just pick numbers from the table. So for example, I'll just pick the whole number first. We have here 90 at 2a. Then we have 180 at a. We have 270 at 0. Then we have 360 at a. And next are the the one decimal places. One decimal place. We have the 30, 1.5. 150, 1.5, 1.5a. Then 210 degrees, we have 0.5, 0.5a. 330, we have there 0.5a. So I think we can now have a quick sketch using this. So we have here the value for radius at 180. Let's find the bigger number here at 90. The bigger number here is at 90. That is 2a. So this is 2a. Then let's go at 180, which is only a here. At 360 degrees, we have here a. At 270, that is 0. At 30 degrees, we have here 30 degrees, 1.5. So this is 1.5. Then 150 is 1.5. Or here. Then we have 210 at 0.50. We have 330 at 0.50. So if we are doing a quick sketch, 330 there. So therefore, our curve will be an inverted heart. So that's our curve. Then we're looking for the area bounded by this curve. So we're looking for the centroid, since this inverted heart here is symmetrical to its sides. So if we look at here, if we divide it into two, then we have similar areas on the left and the right side. Therefore, if we are locating for the centroid would probably be at this point. So there is no problem in locating for the x bar, because by inspection you can have x bar as 0. What we will need to solve now here is the y bar. So to get the y bar, let's first solve for the area. So area is equal to 1/2 integral of r squared d theta alpha to beta. Let's have the alpha at the, let's say, starting here at this point where it became 0, which is the 270. We can start there. Or we can start at 90. So wherever you want to start for the limit, the answer will still be same. So if we get the lower limit at 90, so we will start at 90 and then we will end here at 90. So that means our start is equal to 90 degrees times pi over 180, and that is pi over 2. Now as for the beta, the upper limit, so we started here 90 degrees. Up to this point here is 360 degrees plus another 90 to go back to its starting point. So that means the beta is 360 plus 90 degrees times pi over 180. That is equal to 5 pi over 2. Now, having all the limits that we need, area now is equal to 1/2 integral of r squared. The equation is a1 plus sine theta. So we have there the a1 plus sine theta squared d theta. Alpha is pi over 2, beta is 5 pi over 2. So we now have the value for area. So let's go back to the computer mode or the math mode here. Then area is equal to, again, in solving for the area, use the radian mode. So we now have here integral of, this is squared. So 1 plus sine alpha x squared, lower limit pi over 2. Okay, so pi over 2, upper limit of 5 pi over 2. So that is equal to 9.42. So 9.42. So 1/2 or 9.42 divided by 2. So that is 4.8 So the 3, let's just get the 3 halves pi here. 3 halves pi. A squared square units. Then, by inspection, let's just put here, by inspection, we have x bar is equal to 0. Then for the A, y bar is equal to 1/3 r raised to 3 sine theta d theta alpha to beta. The area is 3/2 pi a squared. Y bar is equal to 1/3 of integral of r, that is a 1 plus sine theta raised to 3 sine theta d theta. Alpha is pi over 2, beta is 5 pi over 2. So 3 halves pi a squared y bar is equal to 1/3 of so let's start from the beginning. 1 plus sine alpha x, so raised to 3. Then sine of, since we're looking for y bar, we have there sine of alpha x, lower limit of pi over 2, then upper limit of 5 pi over 2. That is 15 pi over 4. Is a raised to 3. So y bar is now equal to, so we have there, cancel this, it becomes 5. So that becomes 5, then cancel pi. So 5 over 4 divided by 3 halves. The answer here is 5 over 6 or 0.83. So that is 5 over 6, 8. Therefore, centroid is at 0, 5 over 6, 8. Okay, so that is for example number 2. So that's all for this video.